For axial stress, tensile is positive and compressive is negative, right? This is for axial stress. But for shear stress, as you know, it is something like change of shape. There is a shear force. So you know that the shear force, if we observe in this way, they are in opposite direction. But we cannot determine what is positive or negative. So now I will introduce you what is the sign convention of shear forces. First of all, let's try to understand what is positive and negative surfaces. Consider x, y, and z axis shown here, and those three faces are facing outward. For those three surfaces facing outward, it is called the positive x surface because it is facing outward, and x-axis is the outward normal to the surface. This is called positive y surface because it is pointing outward, and the positive y-axis is the outward normal to this surface. The surface here is called the positive z surface because it is pointing outward, and the positive z-axis is its outward normal. Similarly, this surface, which is not facing to us, is called the negative x surface because negative x-axis is its outward normal. For negative y surface, negative y direction is its outward normal. Similarly, for negative z surface, negative x direction is its outward normal. Let's play again. This is positive x surface, positive y surface, positive z surface. So those surfaces facing to us, and the axis is the outward normal of it, then those surfaces are positive. Then negative x surface. So you can see negative surface and the positive surface, they are opposite, parallel, okay? So this is positive x. And the negative y surface and the negative z surface. After we're talking about the positivity or negativity of the surface, let's talk about the shear force. For the shear force, we still have to talk about its direction. So one important thing I have to mention is that even though, say, you apply a force here, it is upward, then it is not enough to say, okay, it is positive force. Or if you say, okay, if you draw a downward arrow and say, okay, it is a negative force, then still it is not enough to say that. How can we name those shear forces or shear stresses? What is positive shear forces? Positive shear forces means it is acting on positive surface and pointing to the positive direction of the xy-z. For example, this is a positive surface. Your force is pointing to the positive z direction. Then I can say it is positive shear force acting on the y surface pointing to the positive z direction. And this is a positive shear force. Similarly, if you say I have a force like this, is it positive? The answer is yes, because it is acting on positive y surface pointing to positive x direction. Those are all positive forces. For example, tau yz, that means it is acting on positive y surface pointing to positive y axis. And tau yx means it is acting on y surface pointing to the positive x direction. Tau xz means it is acting on the positive x surface and pointing to the positive z direction. And the tau xy means it is acting on x surface pointing to the positive y direction. Tau zx means it is acting on the positive z surface pointing to positive x direction, while tau zy means it is acting on positive z surface and pointing to the positive y direction. For negative surfaces, it is quite similar. 6 possible shear stresses. Tau xy means it is acting on the negative x surface, pointing to the negative y direction. Tau xz means acting on the negative x surface, pointing to negative z direction, etc. As long as the symbol of the surface and your direction are the same, then your shear stress is positive. One problem is that, okay, you might want to ask, what is tau xx? The answer is no, there is no such thing acting on x surface, pointing to x direction. Then what is that? Let me take positive y surface as an example. If a force is acting on the positive y surface, pointing to positive y direction, can we still call it shear stress? No. The reason is that here, this force is normal to the surface. That means now it is the direct stress instead of shear stress. So there is nothing like tau xx. No, it is sigma xx. There is no tau xx, tau yy, tau zz. We only have direct stress instead of shear stress. And similarly for the negative surfaces. So still, for the direct stress, pointing outward means positive. For the sign convention in 2D case, this is positive. Why? Because the force is pointing to the positive x direction. This surface is defined as positive y surface. That means the shear force direction and the surface symbol are the same. So this is pointing to the positive direction and this is positive surface. Then this shear force should be positive. Similarly, it is pointing to the negative direction. It is negative surface. Then it is also positive. Therefore, we can say that this pair of shear stress are positive, or this pair of shear force are positive. And similarly, you can compare those two cases. You can immediately see what is positive or negative. So you can say, like in 2D case, if you shear like this, you lean rightward, then it will be positive. And originally you are like this and you shear like this, then it will become negative shear. And the shear force will become negative as well.